everyone to Weather Watch. This semester I'll be doing the current weather, which is potentially good to get practice in the current weather. So first, this is a look at the week-long infrared temperatures. I'll let it start from the beginning. It catches the end of our cold spell we had around mid-January. So you see it at the start here. You can see this invasion, if you want to play it, of this colder air right here. So what the satellite is actually seeing, it's not clouds, it's the ground being as cold or colder than some of these cloud top temperatures. So you can see there was a push of cold air into the Midwest, and then we were in a bubble of cold air centered over Iowa, and then it became warm again. You can see that the cold air lasts in Canada. You can pick out this, it's not moving as fast as these clouds, but it persists. But if you want winter, as of late, you've had to go, well north into Canada. This cold air was the last cold shot for the entire United States, it looks like. And then we've had a couple of precipitation events you can see here. So first, you'll see a system emerge out of the Gulf and move up. This was our rain, snow, ice event towards the start of the semester. It looks pretty organized, and then everything else is kind of disorganized in our region. There's a lot of precipitation over the southeast, especially Louisiana. They've been in a big drought, so 4 to 6 inches is very beneficial for them. And I'll point out another precipitation event we had. Unfortunately, most of this is rain, so if you are a winter hater, you've been happy. We've started melting, but it's January, so you would expect more snow than we've had as of late. So here's one precipitation event. You can see here's our rain building in. It was scattered at first, and then here's our rain for this morning towards the end there. Sort of just lingering over just Wisconsin into Michigan, it looks like. And then one other thing is the West remains wet. They've had around, maybe normal to slightly below normal rainfall and snow, but you can see they keep getting hammered by event after event. And you'll just notice it just stays. You can make out the clouds that persist over the West and sort of what has been happening over there. I believe that's all I want to say for this plot. Can
you stop it here?
Oh, yeah.
There's a couple cool things right there. Watch the flow at the different levels. You can see, the stuff that's at higher level and cooler and green and yellow and so on is coming from the southwest, and then the stratocumulus is moving to the southeast, and that's cold advection. So just animate a little bit. You can see the wind shear, and then watch when that goes offshore. Now, coming into the 24th, that plume over Florida, and look at the flow that's from the southeast. Is strong warm advection you can see in the winds, just implied by the motion of the clouds. It's really cool. You get tremendous change from cold advection to warm advection in just a couple of days, which of course is related to the passage of the anticyclone and moving to the east, but it's really vividly displayed in the cloud motions. You can see the thermal wind.
That's right, and that I should point out at the very end here. There's another interesting feature that. So this is the first Gulf system, kind of sits and dumps over Louisiana. Then this second produces this mesoscale convective system that's hanging out, and you'll see it more in the satellite, but it has a nice, visible satellite I should say, it has a nice cold pool extending out of it here. Can we go to the climate data, please? Climate page. And we'll start with the temperatures here first. So this is a look at our temperatures, start of January. So you can see we were above normal. The red line is the daily maximum temperature. Our ranges were above normal, so it's particularly warm, above freezing. Then here's our cold spell we had for, about a week. One day temperatures didn't get above 0 degrees Fahrenheit, which that hasn't happened in a while here, I feel like. So that was pretty remarkable, but it didn't last. Quickly jumping up to now we're well above normal, well above freezing, and it looks like we'll continue to stay above this normal maximum temperature range for the next couple of days with highs, maybe in the low 40s, upper 30s, and then lows above freezing or right around freezing. So we'll be well above normal going forward, but you can see there, here's our cold stint that didn't last too long, but brought us 20 inches of snow right before its wake, and we can, you read my mind. So here's Here's our first 2 snows. You can see one big jump of 6 inches at the airport in maybe around January 10th. We had like some lingering snow showers, got another 2 inches, and then we had another 8-inch snowfall within 3 days of each other, which is pretty, not exactly abnormal, but definitely if you weren't expecting winter to suddenly appear and then be below freezing, below 0, this caught you off guard. And then we've kind of had lingering snow showers, maybe sleet mixed in there, but we're slowly approaching our normal snowfall, it looks like, and it doesn't look like we'll have any snow chances in the next coming week, so we might dip below normal for our snowfall. And if we could go to our precip, up here you'll see we're right around normal. We've kind of been lingering in this abnormally dry phase from the Drought Prediction Center, and we've kind of staying in that as of late, as we're just slightly below our normal cumulative precipitation for this date here.
I feel like we're a little below normal band last year too.
That's right. We stayed below normal,
Really?
and we're persisting below normal. So
I think it's really the integrated difference that matters too, because that's what the soil feels, right? Every single day that's in a deficit, you got to add up that deficit over all that period of time, and that's how much it should expect in that interval compared to what it got.
that's right.
And that's huge.
That's
It
right.
looks like a small departure on any day, but integrated, it's big.
That's right. And actually, could we pull up the drought page, please? There was an interesting line of text that I forgot to include in my notes here, but so here, we'll pull up the drought monitor. And so this is a look at the drought monitor. We can click on the Midwest, I believe is where I got it from. Here's Dane County, Madison, where that abnormally dry phase. But if we could slide down to their text at the bottom of this page, please. Keep going, I think it's at the bottom here. Yeah, okay. So you think snowfall, cold, frozen ground, right? This line of text right here, it was reported that insulation from the snow has kept soils thawed in some areas.
Oh, yeah, interesting.
So the snow is producing, it's insulating the soil such that it's staying above freezing. So all of this snow is infiltrating, as they say, into the soil and, helping the drought. Which is counterintuitive upon first thought. I definitely read this and thought, wait a minute, that makes no sense. How could snow, keep the ground above freezing? But it is, because we got so much snow. It was wetter snow. It was just around freezing, so the ground stayed around freezing and then became insulated around freezing.
I think it's more than that. It's that the solid earth is a huge reservoir of infrared radiation, and
Right.
the snow is keeping it from going out. So it's going up there, melting the snow, being absorbed by the snow, and being re-radiated down. So it warms things up. Actually, it actually does warm it up.
That's
from
right.
the temperature that it had before.
And you wouldn't know, based on the roads as of late, that was happening. Kind of was a mess recently, but yes, that is exactly what is happening. Could we pull up go to our surface weather, our satellite page, please, and we'll do the east.
You want just the normal weekly one?
Yeah, or just
Or
the
the morning
couple
one.
hours. Yeah, that'd be good. Visible, please. Do the color viz would be good. So here's a look at the current satellite. You can make out, here's that mesoscale convective system. You can see the outflow boundary of it. Very symmetric around this system and moving in a weird way towards the southwest. A lot of the cloud cover over our region is very low clouds. You can't even see it really moving. Hard to make out if it's snow cover or clouds, but we'll see from the surface obs. Most of this is actually cloud cover, even though there is snow. Some clear skies to our west, but that's quickly being replaced by another system with cloud cover moving in over the west coast. Let's see.
I like the dramatic cold advection over the southern
right.
Labrador Sea. Look at that. It's unbelievable.
Yeah, it's coming, all the way from the Arctic straight down into this system that it looks like there's, could we stop it at the first image, please? From my eye, it looks like here's one system that's probably beginning to weaken or maybe reaching its peak, but then it looks like there's another kink in the clouds. Maybe this is a secondary system right in this cold air advection that's beginning to develop, producing a very nice cloud line, you can see. But largely over our region, it's scattered. If we could start the loop again just for a couple times. It's kind of just scattered cloud cover. You can make out the very beginning, some higher clouds over our region, but most of the Midwest into the, like Arkansas, Louisiana is just this low, very smooth cloud cover close to the ground, which has been present for a couple days now, as we've noticed. It's been drizzly, foggy, rainy, boring, 33 degrees in rain, which is terrible weather. Yeah.
I was just going to add along those lines, the Iowa Mesonet, their front page shows that the last couple days were record-breaking in the number of dense fog advisories issued by the
Is that
National
right?
Weather Service.
Wow.
Oh, interesting.
So, yeah, I think it's on their front page. So this is the just time series of how much of the U.S. was covered by dense fog advisories.
Oh, wow.
Wow.
31% of the United States.
That is very cool.
Interesting.
Yeah, so just along the low stratus
Right.
fog coverage.
Yeah, it's sort of been hard to make out, is it foggy, is it raining, is it doing both, is it doing neither for the last, since January 23rd, it looks like.
Yeah.
We've been the beneficiaries of all of this fog, seems.
What I don't get is when it's snowing out, the ob almost always says snow and fog. When it's raining out, it just often says rain. How come?
Good question.
I don't understand that. Anyway, random, but always been a mystery to me.
I'm just gonna pull up the big cloud base. This will tell you what's going on. I guess it's a little bit. Yeah, we do just the 3-hour samples through the dark. This is an RGB that gives an indication of the level and type of clouds that you're seeing. So the bright sort of pale green in the Dakotas is snow.
Okay.
The sort of cyan colored stuff is low cloud.
Okay.
The red into the yellow is higher cloud. And then kind of the deep blue is like clear land, like over Mexico.
Oh, I see.
And
Okay.
then sort of black is water usually. So that gives you a pretty good idea of whether it's snow, low cloud, or high cloud. And you see all three in sort of our area.
Okay, that's right. You can kind of make out, here's the clearing happening to the west. Pretty dramatically, it looks like. Interesting. Can we pull up the surface weather map, please? There's a couple interesting things happening from the surface out. So first we go to our region. So we're sitting at 35 or 34, a weak northerly wind, and that's light rain, looks like being reported. A lot of haze around the entire Midwest, with some fog into Kansas and Nebraska. Temperatures are largely around between like 35 and 45, I'd say. A wide swath of the Midwest is around that temperature, and there's a lack of true cold air. I mean, it's the end of January. You'd expect this would be the time we're kind of near the coldest temperatures of our year, but you can see, I mean, even into the Dakotas, we have 40s, 45, into Montana where it was negative 40 a couple weeks ago, it's positive 40 now, so this might be a sign that we might be in a warming trend, because there's a lack of cold air around, the entire United States. Into Baltimore, where we're forecasting for 73 degrees. It's January 26th, and it's 73 degrees.
77 just west of there. I don't know if that's.
That's right. Yeah, it looks like
Yeah,
south of
impressive.
DC or something, but
It's not going to be like that next week, though. We're out.
No,
I know, it's gonna be more like this.
Cloudy.
Right.
Yeah,
Yeah.
right, just like this.
and this is a tease. It'll probably, get pretty cold after this cold front moves through. Relative, it'll be in the 50s. But after 73 degrees in January, that's ridiculous. If we could scroll up to Alaska and the Yukon, there's also an interesting observation happening up there. So let's see, here's our cold air. Point out some of these, negative 54, negative 53, negative 60 degrees Fahrenheit. Quickly
nice.
drops off. Yeah, that's right. Quickly drops off though. You're already in the negative teens, coming into central Canada, and then in the 20s and 30s it looks like. So all the cold air is well to our north in Alaska and around the Arctic Circle.
I think it's to the east of Fairbanks, minus 40 and light snow. That's probably spontaneous nucleation. That's
Definitely.
about the temperature where it happens. That's
Yeah.
pretty cool.
No wind, yeah,
Celsius Fahrenheit doesn't even matter. Very cool.
that's right. Yeah, so imagine, negative 60 degrees. I don't even know what that
I know.
is.
You
So,
get to minus 70 and petroleum turns to jelly, apparently. So you're getting close to that.
Right.
Which is amazing. They gotta put engine block heaters on when you get to that temperature to keep the gas from turning into jelly inside the carburetor. It's just unbelievable.
yeah, and this happens routinely in these parts
Yeah.
of the world.
My
which
dad
is
got
crazy.
he was in the Air Force in Fairbanks at Elmendorf Air Force Base, and he's never been back to Alaska. He got out in '54, and they get a sourdough award if the temperature range is greater than 130 degrees while you're there. And he had 98 in the summer and minus 54, so he cleared it by a mile.
Right.
So he still has that.
I can't imagine that being normal. That's just crazy. Could we go do the super peats, please? We'll go to 500 millibars. So we'll look around our troughs and ridges here. And you can notice, so a couple things here. We have a pretty large trough around the entire United States, contingent United States. A shortwave feature, very small, but might be some producer of our precipitation. This is from the morning, so this might be one of the mechanisms for producing our precipitation just downstream of that trough. We're kind of in this, we have a shortwave trough, but there's also maybe a ridge, a very weak ridge, also competing, so that might be explaining some of the clearing happening in the Dakotas and then into Nebraska. Very weak synoptic level flow around our region. I mean, 5 knots at Green Bay. Most of the action is down to the south, which I believe is pretty typical for an El Nino year, but you can notice there's not a lot of temperature variation. 10 degrees from International Falls to the Gulf Coast, so.
Well, and 2 of it's from Oklahoma City to the border with Canada.
That's right.
Right. I mean, that's where.
Oh, yeah.
It's mostly over Texas.
That's right, all the action is well to our south, so we're kind of in this, boring pattern. We're getting this drizzle, it's not really interesting. And then you can notice maybe there's a ridge starting to build to the west, so this might be some indication that we might be in warmer temperatures going forward. Once we get this trough to move through the United States. But larger though, you can also see there's temperature gradient in the southern United States, and then there's one well to the north into Canada, and we're sort of in this, it's basically near the same temperature for a lot of our region and a lot of into central Canada, it looks like.
I don't know if I've ever seen a late January weather map with a jet at 500 millibars across northern Canada.
Yeah,
I've never seen that.
right.
I don't think. That's so weird. And you'd imagine there's going to be lee subsidence like near Great Slave Lake and places, not at this level, you won't see it, but maybe at 850.
Yeah.
So there's talk about destroying cold air at the ground.
Right.
And maybe even gobbling up snow.
Oh, definitely, yeah.
Wow.
I can see that. I mean, the rain's doing that for us, but you have temperatures, around freezing and sunny, you're going to lose some of your snowpack. And I'm not particularly sure how deep the snow is, where we kind of expect it for our cold air to move towards us, but might be some indication that we might, our 7 days and then now we're back.
That could be. That might be.
We
That
just
might
know
be.
in a week of cold.
Right.
That's
Yep.
it.
That might
At least
be.
we got winter, maybe. We go to 300, please. And I'll end with a look at our jet stream level. So here's a look at the jet stream. It mirrors fairly well with the 500 millibar, where we have a dip in the jet stream over our region. I'm going to say this, it might look like, this might be a big cold air outbreak. We have a dip in the jet stream. However, the jet is kind of split. We have this, jet that extends down into the southern United States over Texas, and then one well up into Canada and northern Canada. And we're in the no man's land region again. But if we go to 200, so we'll see we had, we can just look at our jets. We're in the, white color shading and the purple down into the United States. If we go up to 200 millibars, please. This jet completely disappears. This one, maybe it gets intensified, but it definitely intensifies over the mid-Atlantic states. So that's some indication. Here's your polar jet, way up into Canada, and here's maybe a subtropical-like jet that extends over our region. So sort of explains, even though we have a dip in the jet stream, we're still fairly warm for this time of year. All the cold air being trapped well to our north, with no sign of any disruption in that. It extends all the way across from Alaska to Greenland, fairly zonally. All the action is with this subtropical light jet to the south, it seems. So that's all I had for the current weather. Are there any questions or comments? Something anyone wants to see? Oh yeah, here's our drizzle.
Talk about having a target on your back. Gee.
Right? Yeah, this is the only snowfall across the United States at, disregarding the mountains that are most likely seeing snowfall, but into Maine is the only snowfall. Everything else is rain. And it's January 26th.
Yeah.
That's weird.
Thanks, Patrick. Thanks very much. It's the anniversary of the Cleveland Super Bowl, 46 years ago today. I think until the storm we had in October of 2010, that was one of the lowest sea level pressures ever, 958 millibars or something like that. It came 6 days after we had a 20-inch snowfall in my hometown, and that turned all of the high snowbanks into dams for the 3 inches of rain we got. And then that froze because it was really cold afterwards, and the roads were ice. And then on the 5th and 6th of February of 78, just 14 days later or something, or 11 days later, we got the blizzard of 78, which is why I'm standing here in front of you. Because that back-to-back, it was like Ali and Frazier for me for 2 weeks. It was just incredible. I couldn't believe how lucky I was to see those events. So nothing like that happening this January 26th, as you can see. I'm going to do a couple of things. I want to look at the jet over the Pacific, which is remarkable in the Northern Hemisphere jet. We won't do that quite yet. And then zero in on what that seems to say about the weather for us, especially in the Middle Atlantic coast on Thursday. I have a feeling there'll be a little bit of snow flying around in Baltimore on Thursday. That's pretty far out, but let's take a look at that. But before we do, let's go here, Pete, to look at the cold pool, which is just fascinating. This is this year's 850 millibar cold pool. I measure it every day. So I figure out where the temperature, I don't figure it out, it's easy to do. Calculate the area where the temperature is -5 or colder in the Northern Hemisphere. And that covers millions of square kilometers. And then I can do a daily time series of that. So here's this year's daily time series. The blue line in the middle is the daily average from 75 plus years of NCEP and GFS data put together. And then this is one standard deviation above the average. This is one below the average for that calendar day. And then each blue bar represents the extreme minimum aerial extent and maximum aerial extent on any given calendar day. So you get a lot of information at once there. And then the red line is this year's time series for each day from December 1 through January 25th is the last day that I have plotted it. And our cold spell from the 14th to the 21st is in this yellow shading. This tells you a lot about what happened in the hemisphere. There was a big buildup of cold air from some of the lowest values that it ever gets to in January, early January, a huge buildup, and it was the discharge of that cold air and its erosion around the hemisphere that coincided with our cold snap. So I don't know what the picture, because it's been break, I haven't been thinking about the whole picture of the 850 millibar -5 isotherm. My suspicion is we had the big drop of cold air into central North America, and it had to have been more than compensated by an influx of warmer air somewhere else in the hemisphere in an unusual, anomalous way. And we have continued to drop. So now 25th of January was almost the warmest by this measure ever. And if we continue this, we're really going to head into some territory early in February where we can pick off Groundhog Day. It's a little bit smaller area of extent than we had today, or yesterday. So all told, from December 1 to the 25th of January, this is the 5th warmest in 76 years. That surprised the heck out of me. I had to do the calculation twice because I didn't believe it. But the only day we've had 2 different excursions, 3 I guess. One in early December, we were a little bit above the daily average, again in mid-December, and then just right here at the beginning of our cold snap. Other than that, much of the time has been spent at one standard deviation below the normal for this winter so far, around the hemisphere. So it's been unusually warm, and that has mostly jived with our own experience here, but not the last 10 or so days where we were the beneficiaries of a sliding and an erosion of cold air right over us. But you could see it in the satellite picture, couldn't you? How that the really super cold air was just there for 2 days, and it did erode. It didn't come back on the third day when the sun went down, because it just goes away. It gets modified. And so, and that's, I think, how the hemisphere loses, you know, a buildup of cold air is through these little dollops, these little droplets. That's what happens. I mean, they're droplets on the continental scale, but they're still droplets. They come out in a little swirl, they get to low latitude, they find themselves too warm, and they just disappear. And that's the end of it. So, that's just an idea. But anyway, that's what's going on with the cold pool, which is fairly interesting. It's been a really warm year, even in spite of our local cold snap. So can we go now, Pete, to the, I guess we'll go to, is it pivotal weather that allows me to draw cross sections? I think it is, right?
That was tropical.
Tropical, I can never remember, so I always get the wrong one up there. So let's go to tropical, and we'll go to the Pacific Basin. And you could almost see it on the maps that Patrick showed us. They don't go all the way across the Pacific Basin, but you could see that really the nose of a jet at 300 millibars as well as at 200. Where's the best one? Here is it.
North Pacific.
North Pacific. Yeah,
In the
where is it?
bottom, the third one, bottom.
Oh yeah, there it is. I can never find it. So here's North Pacific, and let's get the, first of all, before we even go to the jet, a lot of sea level pressure minima in the 960 to 970 range. I mean, this is one after another. And tremendous varieconicity. Here's Japan, southern Japan. So tremendous varieconicity in the 1,000 to 500 thickness. Kind of disrupts a little bit by the time you get to the longitude of Hawaii. But that's an extraordinary variclinic zone. One won't be surprised to find a strong jet there. But wait till you see what it looks like. And all this activity is, of course, on the cold side, which is the poleward side in our hemisphere of the jet. So let's go to 300 millibars or something, upper dynamics. 250 millibar winds is, I think, a possibility. Yeah. So look at that jet. And that's a 6-hour forecast. This is maybe the most extended jet I think I've ever seen, or close to it. I wish Maria was here. She'd really like to see this. Maybe she's looking at it at home. But Hawaii's about right there. I can't see it on the map. There it is. There's Hawaii. So it's right about there. And usually the jet, Pacific jet is confined to the 20 degrees to the west of Hawaii. Here it's 20 degrees or more east of Hawaii. And it's straight across the basin. So this is clearly an extended jet, top SOM node for the extended jet. Let's do a cross-section, Pete. I guess we'll do it right here. Could be anywhere along this thing. And we'll go straight through the axis of the maximum wind. So bring that over here a little less. Right there, perfect. And let's just see what PV looks like. This will be interesting too, but it's not the one I want. And there must be a lot of people looking at it because it's taking its time. So submit. Here's a strong variclinic zone, but it only goes to 300 millibars in this and comes all the way down to 500. Oh, wait till you see this. Look at that. So 190 knots. There's really no double tropopause. There's a tropical tropopause, and then there's a polar tropopause. This jet is at 190 knots, and you've got a stratospheric extrusion down to about 600 millibars in this case, with a strong horizontal temperature gradient, unsurprisingly, and really strong vertical and horizontal shear. So this is not a place you want to be, unless you have your tail to the wind. You get across the Pacific really fast today. Tokyo to LA will be cut in half today. But LA to Tokyo, they're going to go this way and then come down the Kuril Islands. I think that's probably smarter. This is amazing. I don't know if on our Weather Watch pages we have the jet diagnostics page. If we do, let's see if this is superposed. I would not be surprised. This is 340 degrees Kelvin right through the jet core. So it's, I haven't been keeping up with that, so I'm looking at this.
I don't recall if I've got
There was a time when I thought you did. Yeah, jet diagnostics. Here it is. So let's see if there's anything here. This was at 0Z. Let's see what if the 12Z's been updated, and we'll take a look at this one right here. Maybe it's not running anymore. Is there any of them running? Probably not. I gotta fix that. Okay, so what we do is we look in 2 different isotropic layers, and we find out where the jet core is, and then all we're plotting is the background speed. I don't think there's anything else put on there. But my contention is, I think just by looking at that cross-section, that this portion of this jet, maybe the whole thing across it is superposed. It's really a vertically superposed polar and subtropical jet. That's where the polar jet has gone in this part of the hemisphere. And then Patrick gave us a nice description of, I think this is actually the polar jet in the northern hemisphere over continental US, and this is an extension of the subtropical jet. But that's all hearsay, because I don't have the data on top of it, unfortunately. But that gives you a hemispheric view of what the jet looks like. And of course, that's going to have an impact on the weather over North America in the ensuing days. So let's take a look at the forecast now that we've looked at the jet. And I should have had more of that stuff ready. It's just been one of those weeks. Let's go to your pages, Pete. I like your Python pages. So let's go to 500 millibars and 24 hours down, because we got to watch the clock here. So here's 24-hour forecast that's valid tomorrow morning at 7 a.m. One can see the really strong geopotential height gradient at 500 millibars west of the date line, which is right about there. That's a manifestation of that jet. Just pixelated vorticity structure here. And then here's our upper trough that Patrick was telling us about. And he noted at the last minute the 300 millibar jet was on the west side. That tends to dig these things and make them a little more intense. The vortex structure of this thing by tomorrow morning is pretty intense indeed. And then you get places where there's negative vorticity in the purple, and that undoubtedly corresponds to probably convective precipitation. We'll see that when we look at the forecast at sea level and for the precipitation. So it's a pretty decent looking upper trough, but as Patrick noted, it's not got any particularly strong baroclinic zones to work on either at this level or below it. It's just not baroclinic across the southeast United States right now because all the cold air has been dammed up in the polar vortex, which in our part of the hemisphere has retreated exceptionally far north for this time of year. So let's take a look at 850 millibars here, Pete, at the same time. And there's the beginnings of our development that's near sea level. It's right on the Arkansas, Louisiana border. And so you can see pretty strong cold advection across the Texas Gulf Coast into the Gulf of Mexico, and then moderate warm advection across the Tennessee River Valley. And so that's going to be the region where we have some development. It's just immediately downstream of the upper trough. Let's see what's going on here in terms of forecasted precipitation over Mississippi and Louisiana. So there you go, right across central Mississippi. This is about where we had the negative vorticity at 500 millibars. My contention is these are convective towers, and they are taking convectively unstable air, where d-theta EDZ is less than 0. That means it's negative moist PV. And it's being thrust upward to 500 millibars, where suddenly the stratification is no longer unstable, even potentially unstable, and it shows up as negative vorticity in order to conserve the moist PV. And so that's what's going on in that conjunction, anyway, of those two things. You can see there's a little bit of a thickness ridge that's built there, and that's about where our cyclone's trying to develop. But it's weak. It's 1,011 at the ground. Even with a fairly potent upper trough, it just doesn't have much oomph, probably as a consequence of the lack of baroclinicity. So as we head to Baltimore, this is the system that gets us concerned, not overly concerned, but just one has to pay attention to the weather that arrives with this. So let's go a day in advance. We'll go to 500 millibars first. And so I don't have to tell you what that probably signifies. I bet there's strong convection off the Carolina and Mid-Atlantic coast. Baltimore's right about there. There might be some convection over southern New Jersey as well. This is a pretty decent looking upper trough, but there's not much curvature here. It's broad. There's a strong shear vorticity maxima here, but it's not aligned in a way that really is going to contribute much to a lot of more development at sea level. And so we're really going to see weather produced by this, but perhaps not so much a cyclone. Let's see if that's the way it looks at 850 before we go to the surface. Yeah, a little bit more development, but not an extreme amount. This is starting to look a little bit more coherent as a circulation. And we're right at sort of the apex of the warm sector here in Baltimore by Sunday at 7 a.m. So cold front to our south and west, and the warm front to the north and east. And that's about where you are if you're right at the apex. Let's see what it looks like at sea level pressure. We were 1,011 millibars before. A day later, it gets down to like 1,004. And that's to the west. Maybe it's orographically enhanced. It's 1,008 millibar isobar. That's this one right here over Carolina and parts of Virginia. So it is a little bit of precipitation. It doesn't look as intense as I thought it might, given the signature at the 500 millibar level. And this is not very intense precipitation. I know the scales down here, we're talking about 500ths to maybe 1/10 of an inch generally, and we get into the blues, we're 1/4 inch or more far afield from Baltimore. So it's going to be just like the weather is here. And maybe no snow on the ground will be the thing, so maybe we won't have as much fog potential, but it's going to be otherwise very, very similar.
This is early in the morning, though, too. Some of the convection could have happened the previous day and left that signature.
Maybe that's right. Yeah, because that's right. Those vortex signatures will stay a long time. So it could be residual from prior events. So yeah, there's our cyclone. We'll pay attention a little bit more to that in just a minute. Don't forget our extraordinary baroclinicity here with the Pacific Jet. That's really strong, and there's a cyclone at the tip of it that's already 972 or so millibars. That's an intense little beast. Okay, let's go to 72 hours, Pete. This will get us to Monday morning. We're arriving for the Dan Kaiser Symposium around this time. Again, a strip of negative vorticity. So there's a shear line right here that's, or a jet right here that's kind of giving you positive shear on the cyclonic shear side and anticyclonic shear on the other. The trough has gotten a little bit less intense, a little more flabby, I suppose. There's confluence forward of it, which is going to have some influence on some of the cloud shield over maritime Canada. And then we're going to all have left Madison behind. Won't matter. It'll be Detroit and Cleveland that have to worry about some weather from that little vortex strip. Let's see what it looks like at 8:50. And the storm looks a little bit better organized. The baroclinicity certainly has gotten a little bit more intense, especially in the Wamperl and then on the western side of the cyclone portion. Baltimore being there, we're going to be quite a bit chillier by the time we get to Monday morning, but northerly flow probably means precipitation may have moved itself offshore as well. Let's take a look at that. Yeah, most of the precipitation's offshore, but there's a strip of pretty decent convection and perfectly lines up with the negative vorticity at 500 millibars. So that's a persistent element of this development. There's something driving consistent, probably convective precipitation, and it just won't quit. Now, it can be a feedback. If you have negative vorticity up there at 500 millibars, any lateral displacement allows free displacement, and that's going to produce upper divergence. And so these things can feed back on themselves once they get going. And to my knowledge, Andrea, please, if I'm wrong, to my knowledge, there are not many studies that ask that question.
Yeah, I think most of them are about just how we don't resolve that well.
Yeah, and I think that you could do a diagnostic study of that and see if that interaction really does prolong, the lifetime of such a feature in a non-cyclogenetic environment. Maybe that's one of the keys. If it's non-cyclogenetic, that's the only thing that survives. But that might be the right laboratory in which to study that interaction. Because this is now only 992. It's hardly developing. It can't. The upper trough is weak. But it's persistent convective flying, which is pretty interesting.
What's going through my head right now is just the downstream baroclinicity and how you have this convective thing that is now having its outflow interact with this downstream.
Yeah, right.
And this upper level trough is just coming off the right. Is there going to be a huge cyclone over like south of Greenland?
Yeah, right in here.
Yeah.
It's an incredible baroclinic zone, right. And so, yeah, and it's frontogenetically active from the irrotational part of the wind here probably. Yeah, that's a really good question. It's a really good question. And there's Greenland, the tip of Greenland, so it would be right at the mouth of the Labrador Sea if something interesting really gets going there. Very interesting point. Let's skip ahead at sea level pressure for the next couple of times. We have to get out of here in a minute. Just to see what's going to bear down on Baltimore. So it looks like on Tuesday we'll have a pretty nice day. No precipitation anyway, but not particularly warm. This is the 540 decadimeter thickness line. So it'll feel like it does here. It just probably won't be more than light clouds and certainly not raining. So let's go to the next day. How do we wake up on Wednesday? And then that's the encroachment of this thing that kind of slid down in the northwesterly flow. It's very weak, 1,010 millibars. Maybe we see a little bit of drizzle sometime during the day, or maybe even a snow flurry on Wednesday. And I thought this has the potential, and we'll have to quit without talking about it more, but let's go to the Thursday morning. This one has the potential to develop a little bit more offshore. Yeah, if this thing gets offshore where there's stronger standing baroclinicity, continent versus the Gulf Stream, and it gets a little more intense, the precipitation starts to flare up, and this is early Thursday. I think that there might well be a flurry or so on Thursday. Let's go to 18Z, 6 more hours ahead, so midday Thursday, just for the fun of it. It kind of encroaches a little bit inward, westward, towards the coast. And so if this develops in this fashion, it's going to suddenly get windier. ASC fluxes are more intense. Maybe the precipitation gets itself wrapped up a little bit better. And who knows, maybe it just encroaches a little further to the west and you're suddenly in a snow squall on Thursday afternoon in Baltimore. If it happens, I won't be surprised. If it doesn't happen, I'll be kind of gratified because the model doesn't say that it will right now. But if it does, I wouldn't be surprised. So that's a little thing to worry about at the end of the week. And we're seeing no consequence yet at all from that incredible jet across the Pacific in terms of developments. Something tried to get going here and it just didn't. mostly anticyclone to the north. Interesting, really interesting feature there. I'm not sure I understand it, so I want to keep my eye on that. And that's all I have. And it's going to be difficult to prepare things this semester. This was a particularly difficult week. Hopefully I'll bring some Vis 5D in when we get to the forecast as the semester goes on. And we have more interesting weather systems, so I'll be able to take some time to do that. So thank you all for coming,
Are we
Patrick.
doing
Thank you
this
for a
next
good
week?
discussion.
You're back next week, right?
I'll be back
I
next
should be back
Friday,
next
so I'll be here Friday, yeah. So we will be going on with this. Pete, thanks for driving. Patrick, thank you very much.